Welcome to our exploration of silicon wafers, the unsung heroes behind the technology that powers our world. Silicon wafers are the backbone of modern electronics, forming the essential base for microchips in everything from smartphones to supercomputers. Throughout this video, we will delve into their intricate production process, diverse applications, and the cutting-edge innovations shaping their future. But first, let's understand why silicon wafers hold such paramount importance. These thin slices of silicon are foundational to integrated circuits, which drive the functionality of nearly all electronic devices. Without them, much of the technology we rely on daily would not exist. This video is designed to educate and inform, providing an in-depth look at the silicon wafer industry. We'll cover the history, from its early development to modern advancements, and address the challenges faced in production. By the end, you'll have a comprehensive understanding of how silicon wafers contribute to various sectors, including electronics, renewable energy, and medical devices. As we proceed, we'll hear from industry experts who will provide deeper insights and share their perspectives on current trends and future prospects. Stay with us as we embark on this journey, beginning with the fascinating history of silicon wafers and moving through the precise steps involved in their production. The complexity and significance of silicon wafers are truly remarkable, and we're excited to share this knowledge with you. Let's begin. The journey of silicon wafers began decades ago, marking the dawn of modern electronics. In the early stages, the development of silicon wafers faced many challenges, yet, through perseverance and innovation, key milestones were achieved. From the first successful production in the 1950s to the rapid advancements in the 1970s and beyond, each step represents a significant leap forward. As we trace this evolution, we see how these tiny slices of silicon have transformed the technological landscape. Understanding this history is crucial, as it lays the foundation for the intricate processes and applications we'll explore in the segments to come. So, let's embark on this historical journey to appreciate the origins and evolution of silicon wafers. At the very foundation of silicon wafer production lies one of the Earth's most abundant elements, silicon, primarily extracted from sand. This segment introduces you to the raw materials and initial processing steps essential in silicon wafer manufacturing. Silicon, in its natural state, contains numerous impurities that interfere with its electrical properties. Therefore, one of the first critical steps is purifying silicon to attain the required level of purity for semiconductor use. This process involves converting raw silicon into a gaseous compound and then reducing it back into pure silicon. Once purified, the next stage is forming the silicon into ingots. The process transforms the purified silicon into cylindrical crystals capable of further processing. These silicon ingots are foundational blocks, meticulously crafted to ensure the highest quality and performance. This stage of transforming raw materials into usable silicon is key to the production chain. As we delve deeper, you'll discover how these ingots are transformed into thin, highly efficient silicon wafers. The seamless transition from raw sand to silicon ingots reflects the industry's commitment to precision and quality. Next, we'll see how these ingots are sliced and polished to perfection, getting closer to their final form as integral components of modern technology. Now let's delve into one of the critical stages in silicon wafer production, wafer slicing and polishing. This process begins with ingots, large cylindrical pieces of purified silicon. These ingots are meticulously sliced into incredibly thin wafers, each only a fraction of a millimeter thick. The slicing must be precise to ensure uniformity and consistency, which are crucial for the performance of the final product. Once sliced, these wafers undergo extensive polishing. This step is essential to achieve an ultra-smooth surface, free of any imperfections that could affect their performance. Polishing not only enhances the wafer's appearance, but also ensures it meets the stringent quality standards required for further processing. But the journey doesn't end here. Rigorous quality control measures are in place to examine the wafers. Each wafer is inspected for thickness uniformity, surface defects, and overall quality. Only those that pass these stringent checks move forward in the production process. As we continue our exploration, we will uncover the next crucial steps that turn these polished wafers into functional components of electronic devices. In the world of semiconductor manufacturing, doping and etching are crucial processes that impart essential properties to silicon wafers. Without these steps, our modern electronic devices would not exist. Let's start with doping. This process involves introducing impurities into the pure silicon wafer, which modifies its electrical characteristics. By carefully adding specific dopants, we can control the wafer's conductivity, creating either N-type or P-type semiconductors. Next, we delve into etching. This technique involves selectively removing material from the silicon wafer to create intricate patterns and structures. There are various etching methods, including wet and dry etching, each serving a unique purpose. Wet etching uses liquid chemicals to dissolve undesired material, while dry etching employs reactive gases for precision. Together, doping and etching form the foundation of semiconductor creation, transforming plain silicon into sophisticated, yet functional components. As we move forward, you'll see how these finely tuned processes come to life, enabling the incredible capabilities of modern electronics. At the heart of modern microelectronics lies the art of photolithography. This incredible process harnesses the power of light to craft the intricate circuit patterns essential for our technology-driven world. Imagine a silicon wafer, a pristine canvas, ready to be transformed. The process begins with a photosensitive chemical coating, known as photoresist. This layer, once exposed to a pattern of UV light, reveals a blueprint of the desired circuit. The precise alignment of light and patterning masks allows for the microscopic intricacies of each circuit to be meticulously etched onto the silicon wafer. Through a series of chemical baths, the unexposed areas of the photoresist are washed away, leaving behind only the desired circuit pattern. The importance of photolithography in microelectronics cannot be overstated. Each layer of the circuit is built with unmatched precision, ensuring the functionality and reliability of chips found in countless electronic devices. From your smartphone to the most advanced supercomputers, photolithography is the unseen artist behind the scenes. This critical process ensures that each component performs exactly as intended, maintaining the delicate balance needed in our fast-paced, technology-driven world. As we move forward in our exploration, we'll venture into the realm of testing and quality assurance. Here, we will uncover how each silicon wafer undergoes rigorous scrutiny to meet the highest industry standards. Stay with us. In the intricate world of silicon wafer production, testing and quality assurance are paramount. Each silicon wafer undergoes extensive testing procedures to ensure it meets the highest industry standards and quality requirements. Through a battery of rigorous tests, these wafers are scrutinized for defects, electrical performance, and physical integrity. Every step is meticulously monitored, from initial assessments to final inspections, leaving no margin for error. This thorough quality assurance process guarantees that only the best wafers make it to the next stage of production, ensuring the reliability and performance of the technologies they will eventually power. Next, you'll see how these meticulously tested wafers find their applications in various cutting-edge electronic devices, driving innovation in our digital age. Silicon wafers are the silent workhorses behind many of our everyday electronic devices. In computers, they form the essential base for microprocessors, enabling countless calculations and tasks at lightning speed. Each click, each command resonates on a silicon wafer, unseen but indispensable. Consider your smartphone. From rapid processing to seamless connectivity, silicon wafers are at the heart of these tiny marvels. The sophistication of modern smartphones, packed with features from high-resolution cameras to advanced sensors, owes much to these delicate but powerful wafers. They don't just enhance functionality, they make the impossible possible, fitting immense power into palm-sized devices. But the influence of silicon wafers extends far beyond computers and smartphones. Our lives are intertwined with numerous electronic devices, all powered by these remarkable components. From your smart TV that streams endless entertainment to wearable fitness trackers monitoring your health, silicon wafers form the backbone, unseen but crucial. As we move forward, you'll see how these applications are driving innovation and shaping our technological future, continuing to revolutionize the way we connect, compute, and create. Stay tuned. Silicon wafers are essential not only in electronics, but also in driving the renewable energy revolution. They form the backbone of solar panels, capturing the sun's energy and converting it into electricity. Additionally, silicon wafers play a crucial role in energy storage systems, ensuring that the power generated is effectively stored and utilized when needed. These innovations are not just technical marvels, they represent a step towards a more sustainable future. By integrating silicon wafer technology into renewable energy solutions, we can harness clean energy more efficiently and reduce our carbon footprint. Next, you'll see how these advancements are paving the way for a greener tomorrow. In the medical field, silicon wafers are revolutionizing healthcare. They play a crucial role in medical imaging technologies, enhancing the clarity and accuracy of scans and diagnostics. Diagnostic equipment embedded with silicon chips operates with precision and reliability, providing essential data for patient care. Furthermore, wearable health technologies, from smartwatches to advanced fitness trackers, rely on silicon wafers to monitor vital signs and health metrics in real time. These advancements not only improve patient outcomes, but also mark a significant leap in medical technology. As we continue, we'll explore other groundbreaking applications that silicon wafers enable. Despite their undeniable significance, the production of silicon wafers is fraught with several challenges. First and foremost are the escalating costs, driven by the intensive requirements of the production process. Additionally, technological limitations often hinder advancements, creating bottlenecks in the industry's potential to innovate. Overcoming these obstacles is crucial as we look to the future of electronics and technology. Each challenge presents an opportunity for breakthroughs, driving research and development towards more efficient and cost-effective solutions. Next, we will explore the cutting-edge innovations revolutionizing the silicon wafer industry and paving the way for the future. Recent innovations in silicon wafer technology are paving the way for more efficient and powerful electronic devices. Cutting-edge research has unlocked new methods to enhance performance and reduce energy consumption. These advancements promise to revolutionize not only our everyday gadgets, but also complex systems in fields like renewable energy and medical technology. As industry leaders continue to push the boundaries, we are on the cusp of incredible breakthroughs. Imagine a world where our devices are faster, more responsive, and capable of tackling challenges we once deemed impossible. This is the future of silicon wafer technology, and while challenges remain, the relentless pursuit of innovation will undoubtedly lead us to new heights. Stay tuned as we explore what the future holds next. In this segment, we turn to industry experts who provide a comprehensive overview of the current trends in the silicon wafer industry. Their insights shed light on the innovations that are shaping today's market and reveal the emerging technologies that are set to redefine the future. They discuss how these trends are not only influencing production and applications, but are also paving the way for new opportunities and challenges. As they share their perspectives, it's clear that the silicon wafer industry is on the cusp of significant transformation. Stay tuned as we delve deeper into the future outlook, exploring the exciting possibilities that lie ahead. As we step into the future, the environmental impact of the silicon wafer industry cannot be ignored. With growing concerns about our planet's health, sustainable practices are becoming more critical than ever. The industry is now actively pursuing greener methods, from reducing waste to cutting down on energy consumption. Future initiatives are set to transform the way silicon wafers are produced, aiming to strike a balance between technological advancement and environmental responsibility. It's a journey towards a more sustainable future, where innovation and ecology go hand in hand. Stay tuned as we continue to explore these transformative trends in our last segment. In conclusion, we've journeyed through the intricate world of silicon wafers, uncovering their vital role in modern technology. From the raw materials and precise production processes to their applications in electronics, renewable energy, and medical devices, it's clear they are indispensable. As we look to the future, the prospects for silicon wafers are exciting. We see ongoing innovations driving advancements in electronic devices, making them more efficient and powerful. The industry is also increasingly focused on sustainable practices, striving to reduce environmental impact and promote greener technologies. Final Thoughts position silicon wafers as the backbone of our digital age, continuing to fuel progress and innovation. The future is indeed bright for this remarkable technology. Thank you for joining us on this exploration of the silicon wafer industry. As we progress forward, the ever-evolving landscape of technology beckons, promising newfound possibilities and groundbreaking advancements.